अस्सलाम वालेकुम।
वालेकुम सलाम। मेरी आवाज आ रही है?
जी सर।
ओके, तो सभी अपना कैमरा ऑन करो। सुमेरा तुम भी करो। रोल नंबर 8, रोल नंबर 19, कैमरा ऑन सभी। कितने आ गए अभी? अभी तो 14 ही आ गए। चलो so we have 14 students. 15 आ गया, गुड। सभी वीडियो ऑन रखो ना। So let me start. Let me share the screen. हाँ, मुझे बता दो कुछ जो पढ़ा वढ़ा घर पे तुमने कहीं पे है कुछ जो तुम्हें क्या बोलते हैं, कोई कंफ्यूजन, कोई डाउट उसके रिगार्डिंग तुम पूछ सकते हो। हेलो,
हाँ सर।
हाँ बताओ, किसी जगह कोई कंफ्यूजन?
नहीं सर, ठीक है।
ठीक है, चलो। ये बाद में तुम क्या करते हो? तुमने अभी कुछ ने वापस डिस्कनेक्ट कर लिया। ठीक है, तुम पहले सिर्फ चेहरा दिखाते हो फिर बंद करते हो। ओके, सो आई हैव गॉट रोल नंबर। चलो इसको मिनिमाइज करता हूँ मैं। लेट अस स्टार्ट जहां मैंने कल कहा था। अब हम वापस जाएंगे। हमें कुछ, हमारे पास कुछ एग्जांपल्स हैं बानाक स्पेसेस की, नॉर्मल लीनियर स्पेसेस की, नॉर्म्स की। सो वी हैव अ गुड कलेक्शन ऑफ एग्जांपल्स जिनके साथ अब हम थ्योरी को वेरीफाई कर सकते हैं। तो जो सबसे पहले मैंने बोला था, जो मैंने कल शुरू किया था, मतलब शुरुआत में बताया था कि कोशेंट स्पेस जो है उसको हम, उसका नॉर्म कैसे डिफाइन करें। So let us see, let Y be a closed subspace of a normed linear space X. Normed linear space X. Then if we define the norm of the coset X plus Y in the quotient space X by Y by this formula, that norm of X plus Y, coset norm, is equal to infimum over Y belongs to Y, norm of this X plus small y. Let's call this equation star. Then under this norm, X by Y is a normed linear space. Okay. Okay. Further, if if X is a Banach space, अगर X complete है, then X by Y is also a Banach space. तो ये भी complete होगी. ठीक है. हाँ, before that मैं भूल जाऊं, actually हमारे पास दो छोटे से रिजल्ट है जो हम कर सकते हैं. We know that norm of triangle inequality, norm of X plus Y, चलो मैं
प्लस और एक
हाँ क्या is less than equal to norm of X plus norm of Y. It implies that norm of X can be written as norm of X minus Y plus Y. Now applying triangle inequality to X minus Y and Y, this should be less than equal to norm of X minus Y plus norm of Y. है ना? Which gives us norm of X minus Y is greater than equal to norm of X minus norm of Y. This is rather another form of triangle inequality. And how about this? अगर मैं लूं अब इस तरह से, right? So I've got, चलो better है इसको मैं ऐसे लिखूं. Norm of X minus Y is less than equal to norm of X minus Y. Now, since this is true for all xy belonging to X, this is also true for all xy belonging to X. Now consider this. चलो मैं इधर करता हूँ फिर मैं ड्रॉप करूंगा. अभी ये इसका प्रूफ नहीं है, मैं कुछ दिखाना चाहता हूँ. एक सिंपल सा ऑब्जर्वेशन जिससे हमें इंपॉर्टेंट बात पता चलेगी. Okay, how about this minus norm of X minus Y किसके बराबर होगा? Now this is equal to norm of Y minus X. And using this property, this should be less than or equal to norm of Y minus X, which can be written as minus 1 into norm of X minus, but that is equal to modulus of minus 1 into norm of X minus Y. That's equal to norm of X minus Y. So I've got minus norm of X minus Y is also less than equal to norm of X minus Y. Okay? Now, combining norm of X minus Y और minus norm दोनों ही इससे छोटे हैं. इसका मतलब modulus of norm of X minus norm of Y is less than equal to norm of X minus Y. What does that mean? It automatically implies that norm X is a norm है, which is a function from normal linear space to non-negative real numbers, is a continuous function. क्यों? क्योंकि continuity, चलो दूसरे पेज पे करते हैं. Continuity जो है, अगर तुम्हारे पास देखो x जो है, norm is a function from x to non-negative real numbers. So any function from a metric space to another metric space. Now this is a metric space, this is a metric space. यहाँ पर जो metric है वो है d of x y is equal to norm of x minus y, और यहाँ पर जो metric है is d of x y is equal to mod of x minus y. ठीक है? ठीक है ना?
जी सर.
A continuous function between metric spaces is continuous, ये तुमने किया होगा, if and only if whenever xn converges to x, it implies that f of xn converges to f of x. अगर metric space में मैं इतना दिखा दूं, इसका मतलब for all x, तो then it is equivalent to saying that f is continuous. ये metric space की property है. ठीक है? ठीक है ना? उसका मतलब ये हुआ whenever या अगर xn माइनस x, यानी अगर मैं ये दिखा दूं कि f of xn, चलो मैं ऐसे d of xn minus f of x is less than equal to d of, चलो इसका मेट्रिक मान लो d1 है, इसका मेट्रिक चलो d2 है, इसका मेट्रिक d1 है। अगर मैं ये दिखा दूं, it implies that f is continuous. f is यानी अगर इस मेट्रिक की जो है ना, क्योंकि अगर ये लेस देन, if this approaches 0, this automatically approaches 0, क्योंकि इससे लेस देन इक्वल टू है और नॉन नेगेटिव है। तो इसका मतलब अगर xn अप्रोच करेगा x को, then this would go to 0, क्योंकि ये लेस देन दिस है और नॉन नेगेटिव है, तो दिस वुड आल्सो इंप्लाई टू 0, व्हिच मींस f of xn would approach to f of x, यानी अगर xn approaches to x implies f of xn approaches fx, जो कि इस केस में होगा, it would imply that f is a continuous function from between metric spaces, right? तो अगर मैं नॉर्म पर यही अप्लाई करता हूं, यानी मुझे दिखाना है, इसका मतलब ये हुआ, इफ आई शो दैट, जो कि मैंने अभी दिया, कि norm of x minus norm of y is less than equal to norm of x minus y, और ये मेरी फंक्शन है norm, तो it is the same as f of x d2 f of x f of y is less than equal to e2 d1 xy for all xy। तो अगर मैं x की जगह xn लूं और यहाँ इसकी जगह x लूं, तो भी ट्रू होगा, तो ये ट्रू हो जाएगा, which would imply that norm is a continuous function। चलो इसको तुम घर पे थोड़ा रफ भी कर लेना। Not only that, under this norm, using the same thing, that vector addition and scalar multiplication are continuous. By that I mean, if xn converges to some x and yn converges to some y, then xn plus yn would converge to x plus y, and alpha xn would converge to alpha x. तो इसका मतलब ये हुआ कि वेक्टर एडिशन इज कंटिन्यूअस, एंड by using the same idea कि मेट्रिक स्पेस में हम कन्वर्जेंस इन टर्म्स ऑफ सीक्वेंसेस डिफाइन, मतलब एक्सप्लेन कर सकते हैं या कैरेक्टराइज कर सकते हैं। तो ये प्रूव करने के लिए I take this norm of xn plus yn minus x plus y can be written as norm of xn minus x plus norm of yn minus y, and using the triangle inequality, this is less than equal to xn minus x plus norm of yn minus y. So if xn converges to x and yn converges to y, this goes to 0, this is non-negative and is less than equal to this. So this approaches 0, which means that xn plus yn converges to x plus y. Similarly, I have got alpha xn would converge minus alpha x can be written as alpha into xn minus x, which is exactly equal to modulus of alpha into norm of xn minus x. So अगर xn converge करेगा x को, तो ये 0 बन जाएगा, इसका मतलब ये 0 बन जाएगा, which means alpha xn would converge to alpha x. Not only that, huh? So मतलब it's clear. So vector addition और scalar multiplication is continuous. Now what I want to do, ये किसने ये लकीर मारी इसमें? Okay, row number 2 कौन है? So what I want to go back to this theorem. तो मैंने सिर्फ ये छोटी theorem जो तुम actually में home assignment देता हूँ, यानी norm is a continuous function, vector addition is a continuous operation, and so is the scalar multiplication, in the sense that if xn approaches to x, yn approaches to y, xn plus yn approaches to x plus y. So having done that, let's do the theorem. Okay, proof. तो प्रूफ में मुझे क्या, ये हम थोड़ा साइडवेज चले गए, लेकिन प्रूफ में हमें दिखाना है ये जो ये स्टार है, इट डिफाइंस अ नॉर्म ऑन द कोसेट स्पेस. ओके, और अगर x बानाक स्पेस है तो x by y भी बानाक स्पेस होगी. लेट्स स्टार्ट पहली नॉर्म वाली प्रॉपर्टी. फर्स्ट प्रॉपर्टी, क्लियरली नॉर्म ऑफ x प्लस y जो है वो नॉन नेगेटिव, क्योंकि ये नॉन नेगेटिव है और infimum of all negative numbers is also non-negative. So सही है, मतलब पहली प्रॉपर्टी तो ऑब्वियस है. दूसरी प्रॉपर्टी, if norm of x plus y is equal to 0, it implies that, yeah, it is equivalent to saying that infimum norm of x plus y, let me write it like this, such that y belongs to y is equal to 0. ठीक है ना. अब हमें पता है इन्फिमम जो है वो एक लिमिट पॉइंट होता है सेट का, यानी ये जो 0 है, इट इज लिमिट पॉइंट ऑफ दीज रियल नंबर्स, नॉर्म ऑफ x प्लस y. और लिमिट पॉइंट की एक प्रॉपर्टी है कि दिस वुड बी ट्रू इफ एंड ओनली इफ देयर एग्जिस्ट अ सीक्वेंस, लेट मी कॉल इट yk contained in y such that norm of x plus yk approaches 0, right? It implies that, ठीक है, it implies that अब जो ये x plus yk है, it means that x is a limit point of y, which implies that x belongs to y, because y is a closed subspace. Closed set का मतलब it contains all its limit points, which is true if and only if x plus y is equal to y, because y is a subspace also. So if x belongs to y, it is true if and only if x plus y is equal to y, the additive identity. But why is the additive identity of the quotient space? It is the 0 element of the quotient space. ये तुम्हें पता है वेक्टर स्पेस से, तो हमने दिखा दिया. हाँ, यानी अगर x plus y is equal to 0, हाँ बिल्कुल, if of x plus y norm is equal to 0, तो वो भी additive identity है, तो पहली प्रॉपर्टी तो हो गई. The question is of alpha और वो सब, ठीक है ना. चलो दूसरी करते हैं हम, ट्राइंगल लेने की. चलो ऐसे ही करते हैं. Norm of alpha into x plus y would be equal to, it would be alpha x plus y. Definition of the Coset operation. This is equal to infimum of alpha x plus y such that y belongs to y. That can be written as infimum of, should I write it as alpha into x plus y by alpha such that y belongs to y. चलो मैं ऐसे ऐसे लिखता हूँ. Let me write it here. Now we assume that alpha is not equal to 0, because otherwise norm of alpha into x plus y is equal to 0, and norm of 0 plus y is also equal to 0, and there is nothing to prove, ठीक है. तो इसका मतलब हाँ ऐसे में लिख सकता हूँ, 0 into norm of x plus y is also equal to 0. So there is दोनों, मतलब तब तो trivially true है. जो मैं दिखाना चाहता हूँ, मैं क्या दिखाना चाहता हूँ, अल्फा इंटू एक्स प्लस वाई का नॉर्म जो है इज इक्वल टू मॉडुलस ऑफ अल्फा इंटू नॉर्म ऑफ एक्स प्लस वाई। इन केस अल्फा इज 0 देयर इज नथिंग टू प्रूव। ओके, एनीवेज, सो अगर मैं अल्फा 0 नहीं है तो मैं इसको ऐसे लिख सकता हूँ, ठीक है, विच इज द सेम थिंग एज norm of alpha into x plus y such that no y belongs to y. The reason is y is a subspace. Subspace का मतलब if y by alpha, if y ranges over y, then y by alpha also ranges over y. चलो मैं यहाँ स्टार कर देता हूँ. तो y is a subspace if, therefore if y by alpha, therefore if y ranges over this capital Y, so does y by alpha. Scalar multiplication, because it's closed with respect to scalar multiplication, which is nothing but infimum of modulus of alpha into norm of x plus y prime, such that y prime belongs to y, which is equal to mod of alpha into infimum of norm of x plus y prime, such that y prime belongs to y, which is equal to modulus of alpha into coset of this. तो ये दूसरी प्रॉपर्टी हो गई. तीसरी प्रॉपर्टी is, okay, let us start from where we left. We had to prove the triangle inequality for the quotient space, and we had x normal linear space is a normal linear space, and y the subspace of x, and we want to show that x by y is a normal linear space with norm of the coset, with norm defined as norm of x plus y, the norm of the coset is equal to infimum of these norms x plus y as the small y ranges over the subspace y. Now to prove the triangle inequality for this norm, so let x1 plus y, x2 plus y be two cosets in x by y, then by the definition, then for any epsilon positive, we can find y prime, y double prime belonging to y such that norm of x1 plus y, because this is the infimum, is strictly less than, oh sorry, norm of x1 plus y prime is strictly less than this infimum of the set plus epsilon. Now, this is just a definition of the infimum. If you increase the greatest lower bound or the infimum by a little bit by any epsilon, then you can find a member of this set, that means x plus y prime, such that उसका norm जो है वो less than होगा that plus epsilon. So this is just the definition of the infimum. So and similarly, x2 plus y prime, y double prime would also be strictly less than norm of x2. Oh, sorry, I should write x1, x2. So what x1 plus y coset norm, and here I write x2 plus y plus epsilon. This is just the definition. So definition of the infimum is if A is a set of real numbers, and let's call it G or S is the infimum of A, and then for any epsilon positive, there exists some real number x belonging to A such that x is less than the infimum s plus epsilon. So this is just the definition of infimum. It's lower bound with this property. Okay, so once I've done that, now if I want to evaluate the coset norm of some of the cosets, so that would be, this would be actually equal to, using the coset addition, x1 plus x2 plus y, and by using the definition, it is equal to infimum over y belonging to this capital Y norm of x1 plus x2 plus small y, but this would be less than or equal to its infimum. I mean to say it would be less than or equal to x1 plus x2 plus y dash plus y double dash, because this y plus y double dash it belongs to y, so it would be bigger than or equal to its infimum as y ranges over this subspace y, which would be equal to norm of x1. Using the fact that the vector addition is commutative, I can write it as like this. And furthermore, now if we use these two inequalities and the triangle inequality, we get norm of x1 plus y plus x2 plus y is less than or equal to, using the triangle inequality first, x1 plus y prime plus x2 plus y prime y double prime, which by our definition of the infimum of the sets from Nikita, it would be less than or equal to norm of x1 plus y plus norm of x2 plus y plus 2 epsilon, or strictly, sorry, I have a strict impact here. And but since epsilon is arbitrary, it implies that norm of x1 plus y plus norm of x2 plus y is less than equal to norm of x1 plus y plus norm of x2 plus y. So indeed, we have proved that x by y is a normal linear space. Now the second part, which is the more important part of the theorem, is that if x by y is complete in its Banach, if x is complete. So let's pick a Cauchy sequence in x by y and show that it converges. So now this would be a sequence of quotients in xy. So I pick up a sequence of quotients xn plus y, be a sequence in x by y. We show that it converges inside x by y. Oh, I have to take a Cauchy sequence. Be a sequence in x by y, that is Cauchy. Okay, so it suffices to show that xn plus y has a convergent subsequence, because every normal linear space is a metric space. So in a metric space, if a Cauchy sequence has a convergent subsequence, then it must converge to the same level, basically. So in a metric space, if you want to show that a Cauchy sequence converges, it is sufficient to show that sequence has a convergent subsequence. Now Okay, now using the fact that xn is Cauchy, now since this sequence is Cauchy, I can pick a particular subsequence. Cauchy means after a certain stage, the distance between the terms, or the distance between the terms becomes smaller and smaller, arbitrarily small as n approaches, as we approach infinity. So it's possible to find a subsequence. Let me call it xn sub I plus y of xn plus y, such that xn1 plus y, the distance between, that means the length, the norm of the difference of the consecutive sequences, I mean in this manner, is strictly less than 1, because I can choose my sequence. I've got a sequence, say A1, A2, and so on and so forth, and they are becoming closer and closer as we approach infinity. So I pick my first and second term where the distance between them is less than half. And a stage must come where I can find these two terms where the distance is less than half. And then I pick another one so that the distances between the second one and the third one is less than 1/4, and so on and so forth. So this is possible because I have got a Cauchy sequence. I can write it like this, less than 1/2 square, and so on and so forth. In general, I would have xnk plus y minus xnk plus 1 plus y. This is less than 1/2 raised to power k. So this is my general, this is the subsequence I can pick. We prove that this subsequence is convergent in xy. And since I have a Cauchy sequence, I find a subsequence that it converges in xy. Yes, assuming that x is complete, of course. So what we do now, looking at this this norm of the difference of two cosets is less than 1/2, and since this is defined as an infimum, so using the definition of the infimum, I can show that we can pick a vector here and a vector here such that their difference is less than half. So we can choose a vector y1, but you have to be careful. It belongs to xn1 plus y. It's not a vector inside y. And y2 belonging to x sub n2 plus y, such that norm of y1 minus y2 is less than half. Because if that's not the case, if for all vectors here and all vectors in these two cosets, if the difference is bigger than equal to half, then the infimum would be bigger than equal to half. So that's not possible because the infimum of these differences is less than half. Okay, similarly, so then we can choose, we next choose a vector y3 belonging to xn3 plus y, such that norm of y2 minus y3 is strictly less than 1/4, and continuing like this, we obtain a sequence yk such that norm of yk minus yk plus 1 is strictly less than 1 by 2 raised power k. Now these are the difference of vectors inside X. Okay, let me stop here.